Welcome all. So today's session we will discuss about realization of detail filters. So basically a detail filter is a linear time invariant systems which has three terms xn, h of n, y of n. So this h of n is, we call it as, h of n is the transfer function or response of the system, and x of n is the input. X of n is the input of the system. H of n is the response or transfer function. Function of the system, and y of n is the output of the system. Okay, so in order to realize the systems, either you can find h of n or h of z. That is the transform of h of n. So by solving difference equations. So in order to find out this h of n or h of z, we have to solve difference equations. So there is many ways we have to solve this difference equation, which is called the realization of detail filter. So realization of detail filter is the various ways to implement difference equations. So a data filter transfer function can be realized in variety of ways. There are mainly recursive types. So we can realize in the data filter into different types. That is recursive type. So recursive realization is actually the current output y of n is a function of past output, past and present input. So this form corresponds to an infinite impulse response. For recursive realization, the output y of n depends on past output and present and past inputs. Okay, so mainly this recursive realization is basically means to IIR filters, that is infinite impulse response. So where we can find past output, present and past inputs. The output depends on past output, present and past inputs. The another method is for non-recursive filters. Here the output y of n depends on present input and past input. So this is mainly in the finite impulse response. This form corresponds to finite impulse response. FIR. Okay. And here for recursive realization, y of n depends on past output, present and past inputs. It corresponds to infinite impulse response, that is IIR filters. Okay. So now we will see the different technique to realize the digital filters. Mainly we can use we require operations like addition, delay and multiplication by a constant for doing this realization in digital filters. Here I showed some of the examples of adder, that means addition. We have to add two inputs by using an adder, that is x1n is one input and x2n is another input. We can add using this adder and we will get the output y of n. So y of n is the function of x1n plus x2n. Then another method is constant multiplier. Here you will see x of n is multiplied with a constant a. Okay, constant a. So we will get the output y of n equal to a into x of n. Next one is the signal multiplier. Here you can add two signals or you can add two inputs. So here x1n is one input and x2n is another input. You can multiply using this multiplier and you will get the output as y of n equal to x1n into x2n. Next one is the delay elements. Here you can give some delay to your input. So x of n is the input and you can give the delay z raised to minus 1. So the output will be x of n minus 1. So z raised to minus 1 means you can give one delay to the input. Okay, so x of n minus 1. If z raised to minus k, you can give the input to n minus k delay. Okay, so y of n equal to x of n minus k. Next is time advance. So in time advance you can give the input an advance value. So x of n is the input and if we give the z raised to 1, then the y of n will be x of n plus 1. So here we give some advance to the input. Okay, here only 1 raised to 1 value given, so it will be x of n plus 1. If x of n gives z raised to k time advance, then the output will be x of n plus k. Okay, then if you want to get 2 delay, or maybe you can give x of n input 2 different delays, z raised to minus 1, z raised to minus 1 separately, or you can give here z raised to minus 2 delay like this. Okay, only 1, and here x of n, and here you will get y of n. The answer will be same for both x of n minus 2. And here also you can give time advance by giving separate delay advance, but also you can give same z raised to 2. So x of n will be equal to y of n, that will be equal to x of n plus 2, likewise also. Okay, so these are the basic operations that we are going to do for the realization of digital filters. Okay, so next I will show some example. One of of the first order data system equation is written here, a difference equation y of n equal to minus a1 y of n minus 1 plus x of n plus b1 x n minus 1. So in this equation you can see this is y of n is the output. This output will depend on the past output. Y of n minus 1 means there is some delay in the output. That means this term represents the past output, and x of n is the present input, and x of n minus 1 term is the past input. Okay, so this output depends on past output, present input, and past inputs. So this one is the example for IIR filter. Okay. So in this I draw some block diagram of equation 1. So you can see x of n is given as the input, and next point I give one delay is raised to minus 1 with constant multiplier b1. So this portion satisfies this term b1 into x into n minus 1. Okay, then next point there is y of n, that we get it as the output, where I given one delay is raised to minus 1 and it is multiplied with the constant a1. Then we add these two together with the b. So here b we will get the x of n. So all this multiplied, all this added, and we get the output y of n. So this is the block diagram for this equation 1. Hope you understood. X of n already got, and here there is delay with x of n. So x of n with the z raised to minus 1, we will get x of n minus 1, which is multiplied with the constant b1. So it is also added to this portion, and y of n is delayed with the z raised to minus 1. So y of n minus 1 and multiplied with the a1, that is also added. So you will get the output y of n. So here A, B, C and D are the summing points. Okay, summing points or nodes. So this is the block diagram for the first equation 1, and the similar flow graph model is also drawn here. X of n multiplied with the constant and the y of n multiplied with the constant b1. Okay. So the first one is important. This type of flow diagram is drawn for realization of different type of filters. So now we will discuss more about the realization of IIR filters. So realization of IIR filters can be done many forms. The first one is direct form 1 realization. Second one is direct form 2 realization. Third one is cascade form realization. Fourth one is parallel form realization. So many other methods also there: transposed direct form realization, lattice ladder realization. But the main four types are direct form 1 realization, direct form 2 realization, cascade form realization, and parallel form realization.